All right, so here I'm going to do just a little bit of work with a lovely activity called Shelley the Snail, where you're trying to help Shelley get to the piece of lettuce. And the thing to keep in mind here is that a lot of times we start with something that's not super efficient, and then we notice a pattern that allows us to do something more efficient. And so as I go through this video, you'll notice we work from things that are like super concrete and inefficient when you have to do them over and over, and then we get to a more efficient way at the end. So when I look at this problem here, what I'm asked to figure out is how many of the 2 millimeter blocks can I stack up so that Shelley does not, so Shelley has a nice bridge to go through there. So I could try just guessing and checking, and this would be a pretty inefficient way to do it. Let's try 5 blocks there. 5 is way too small. Okay, let's try 25. 25 is way too big. So I could keep guessing and checking, and eventually I would get it. But then when I get to blocks number 2 here, I would also have to just kind of keep guessing and checking. So guessing and checking would be a very inefficient way to do it. Maybe a faster way to do it is to realize that you have a total gap of 36, and you've already got one block sitting right there. So if you go 36 minus 4, you know there's 32 millimeters left to cover. Each of the purple blocks counts for 2 millimeters. So if I do 32 divided by 2, I'll figure out that there's 16 purple blocks that needs to go right there. Let's see it out. Let's see if I did it right. 16 fills in that spot perfectly, but now I still need to do the next one. Okay, let's try the next one. Let's see if I have a similar strategy. Now there's 2 blue blocks, so that means that I'm subtracting 8 because each of those blue blocks is 4. So there's 28. 28 divided by 2 means you've got 14 of the blocks there. So let's see if 14 works. Wonderful. Now the next one here, I could do that same game again. Or I could realize that if you look right here, there's kind of a trade that's going on. 2 purple blocks counts for the same as 1 blue block. And I'm seeing that when I look at the numbers in my table. I'm seeing that as I go plus 1 blue block, I have to go minus 2 on the purple block. So that leads me to a shortcut where I can go 12, 10, and 8 like that. Let's see if it works. So I went from guessing and checking, not efficient. Then I went to these sort of concrete calculations, more efficient, but you have to do a new one every time. And then I went to a pattern, and a pattern where you go minus 2 on the y value and plus 1 on the x value is a little bit more efficient. But what if you had to go a lot of x values in the future? So what if this didn't just go 1 block, 2 block, 3 block, 4 block on the x? What if it went from 1 to 17 to 50? Is there a more efficient way that you could work for any of the x values? And so I want to show you 2 ways that you can get that. One idea is to start with this, that really what we're doing is we're adding up 4 millimeter blocks and 2 millimeter blocks to make a total of 36. And if we do that, we can actually take this equation, which is in standard form, and make it into a new equation that's in our more familiar form of y equals mx plus b, also known as slope-intercept form. And the way we do that is just subtract the 4x. So 2y is 36 minus 4x. By the way, you can see here's 36 minus 4 times 1, 36 minus 4 times 2. And then to get y by itself, you divide by 2. So y equals 18 minus 2x. And I hope you can see here how the minus 2 for every 1 shows up as my slope of negative 2. But weirdly, the 18 doesn't show up in the pattern. And so that's the other way I could have got this answer here, is imagine I had just worked backwards to x equals 0. What number would come right here for the y value? Well, if going down the pattern is -2, going up the pattern would be +2. So we'd have 18 like that. And then you can see the -2 is your M, the 18 is your B right there. Okay? Oops, B equals 18. My pen stopped working. Okay? So the only other thing I wanted to show you in this video is how that looks as a graph when we represent it, instead of looking at it as just blocks with a cute little snail. You can see here that you have some of those dots already graphed, and you can see here some of the work that's going on. These points right here are the numbers that we had in the table. 0 X blocks, 18 Y blocks. 1 of the 4mm blocks, 16 of the 2mm blocks. In general, there's 18 minus 2x. And that equation connects all of the dots. Those dots are each a solution to Shelley crossing to get the lettuce. And 18 minus 2x captures all of the possible combinations, including ones that don't really make sense, like negative blocks or fraction blocks. So the idea of this video is going from really inefficient concrete representations where we're guessing and checking, and then we're doing some very specific numbers, and we're looking for patterns, and then we're getting to an equation. And finally, the graph itself shows all of the possible solutions, even ones that no longer make sense in the context of the word problem of Shelley. So please let me know if you got any questions, and I'm happy to help. Thanks for watching.